Okay, so the very first problem on this set is for the exercise problems. It's to use a spatial join and data from the Austin GeoDatabase to answer the following questions. The first one is a tennis club implementing an after-school program. Use the spatial join to determine the closest tennis courts to each school. And so remember, the very first task with doing this is to figure out which one is the target, that is where the data is going to go to, and the other task is to figure out which GIS layer the data is coming from, which is called the join feature class. And so in this case, almost always in these sentences, they're going to be written in such a way that the destination where you want it to go to, the target, is going to be written last, and so you want to know the tennis court nearest to each school. So that way you want a GIS layer, and a result from this is all the schools, the point locations of the schools, with a new attribute. The table for the schools may end with something like is the type of school, elementary school, high school, whatever. But then once you perform the join, it'll have all the attributes of the closest tennis court as new attributes. And because you have that, and you have the distance to it, so some schools may have a tennis court right on the premise, which would be very close. Other ones might be a mile away, whatever. That'll be another column that's added onto the attribute table of the school. So what's the nearest name of the tennis court? How far away is it? Will be two new columns added onto that table after you perform that join. So that's the gist of this. And then it wants to know what is the average and median distance of the schools to the tennis courts in miles. And so this turns out to be quite an involved problem, because you have to set up that join properly, perform the join, and even after you do, you're going to end up with a new column in the attribute table that's distance in the map units of this overall project. You have to convert it to miles, which requires adding a field and populating that field, and then you have to run statistics on it. So it's like at least a 3-step problem to get to the end of this thing. Perform a join with the right field to add a distance column, convert the distance to miles, and then run statistics. So those are the 3 steps we'll perform. So for this, if I was to have a brand new project, I'm just going to start a new map for this then. So I'll go to Insert, a new map, and I'm just going to call this new map EX1 for exercise problem 1. And then I'm going to go to my map and go to Add Data. There, it's got a new map. I'm going to close down this attribute table, just a brand new map. Remember that whatever GIS layer you add first to your project, it's going to set the it's going to set the coordinate system to that very first layer you bring in. So whatever the coordinate system of the schools or the tennis courts are, which hopefully are in the same coordinate system, it'll switch the coordinate system over. The reason I mention that is because it makes the right coordinate system as you zoom into Austin area, and it makes it look right. And then it also sets the units, so that when you compute the distance later, you'll know what those numbers mean. Are they meters or are they feet? Are almost always the 2 choices, and that'll help you with that conversion to miles later. So let's go ahead and add those 2 layers in. I'm going to start off trying to find the tennis courts layer, and I find that here in the parks in the Austin GeoDatabase. And I'm just going to check real quick right now and make a note of the coordinate system now that I've added this one in. And for that, we need to go to the Source tab in the Layers property, and we'll go down to Spatial Reference. And it turns out it's telling me here that it's in State Plane, Texas Central, and that in parentheses at the end it says horizontals in US feet. So when we get a distance column later, which we'll know that that's in units of feet. We just divide by 5280 to turn that into miles. So that's coming later. Okay, so I have the tennis courts. Now I need to find the schools. So hit the Add Data button again. This may be in Administrative. Let's see if we find schools. Anybody remember where it is? Facilities, probably. Yeah, schools are there. So if we took the time for it, we could have a little icon for school buildings for each of these, like a little schoolhouse, and then maybe like green squares for tennis courts. You can make this look nice. We don't necessarily need to do that, but one of the things I always like to note is how many relative features are there. There's relatively few tennis courts, in my mind, to the number of schools, and the idea here is that in the end, we want to know for each school, each one of these dots on here, which one is the nearest single tennis court to it. And so we want the attributes of the tennis court to be appended onto the attribute table of the schools. Now, because there's Again, we don't have to worry about too much on this because it's the nearest. So the nearest tennis courts are going to give up its attributes to the schools in this case. So it kind of makes it a one-to-one relationship for cardinality. I always like to check on this to see what the attribute table looks like before I perform the join. So if I look at the schools right now and I scroll all the way to the right, we see that it tells about what's the grade levels of that school, the institution type, is it a regular school or whatever it is, and then there's a street address. And that's the last attribute as of the school's feature class. After we perform the join, our expectation is that there will be another set of attributes added onto this table that correspond to the nearest tennis court for each of these schools. And again, just thinking about it logically, since there are more schools than tennis courts, some of those tennis courts will be closer to probably 2 or 3 schools, and so that it'll end up repeating its value. So in that sense, it's probably more like a many to one. It's not a problem. It's just that there are relatively fewer tennis courts that are going to give up its attributes to multiple records here. All right, the other thing, when the three of us were solving some of these last nights, there are 2 ways to perform a spatial join, and this is a relatively new feature of the latest release of Arc Pro, that they have 2 ways to get at this. I find, and I have just like in my own way, I have not worked with the geoprocessing option as often. The way that you used to get access to performing spatial joins was you would right-click on the target feature class and initiate the join by clicking on it from the table of contents over here. And that's the way I'm going to demo it today. We tried it last night and it worked well, so I'm just going to use that for my demo. The other way to get access to the spatial join tool is to go to the toolbox, and you can search in spatial join. It comes up that way. And it's just a slightly different tool with some more options, and I find them to be a little bit, personally I find them to be a little bit confusing. Sometimes they don't result in the result that I'm looking for. So let's do it the way that I know works, and that is we right-click on the school's feature class and then go to joins and relates. And in this list of joins and relates, you can do it. This first one is add a table join. This middle one is add a spatial join. Remember, the one you have to have a similar field in both attribute tables. This is just all based on proximity, spatial join. So we do a spatial join here. It automatically then, for the target field, tells us that we're going to have the schools, and then we need to tell it which GIS layer is our join one, which is the source, where it's coming from, and that's going to be the tennis courts. And then for the match option, we have all these different choices: intersect, overlap, within a distance of, and so forth. Because, and I don't know why they put this at the bottom of the list because it's quite a common one, is there is a closest, and that's the one we want to use in this particular case. So again, we're setting this up with the target layer as our schools, the join layer as our tennis courts, and we're doing closest as our setup. We don't need a search radius for this one, but we need one for a future problem. We can leave the search radius. That's the next option down. We can leave that one blank. And the next one is the distance field, and we want to be very deliberate about this. We want to call it, it's not going to give us an option to change units. It's just going to provide a GIS, a call in the attribute table for distance, and it's going to be in the units of our coordinate system. And so what I like, just to make a note to myself, not to get it confused, I'm going to call this distance, and then underscore, and then I'm going to put in there, you can write it out in full, distance and feet is what I wrote out here, and I have an underscore. You don't want to have any spaces in a column title, so I make it an underscore for this one. So that way when I see those numbers later, I'll know they're in units of feet, and it'll help me with doing the conversion. Okay, for this one, because we're not doing a problematic one-to-many, where you're trying to squeeze multiple records into one, we don't need to open up the fields, although on future problems this is going to be a critical step. But for this one, just being nearest, we don't need to worry about that, the fields for right now. I'll explain that one later. So once you have it set up this way, schools as the target, tennis courts as the join, it's the closest, and we have a distance field. I'm going to click OK, and we'll know this works if there's more attributes on the table, and in fact we see there are. Remember the last time it was some kind of an addressed field? That was the furthest column to the right. Now everything past this point has to do with the tennis courts. The nearest tennis court to each school, and that's what we're looking for. So step 1 complete, perform the join. Step 2 is then add a new field for the distance in miles. Step 3 is to convert the numbers from feet to miles. And so the joins seem to have gone well. We just want to look on here to see if we have a distance field, and there it is, distance in feet. That's the one I just added on, but again, that's in feet. We want it in miles. So the next step, this goes back to the whole chapter on attribute tables. We need to go to the Add button right here. When we click on the Add button, it allows us to add a new field onto the attribute table, and we're going to call this distance. If you really wanted to be specific on this, it would be distance to tennis courts, like distance from school to the tennis courts. But I'm just going to say dist, and then in miles, because we know what this is. Make sure you change the data type to float. That'll give it decimal places. And then when you have that done, up to the top here and hit save. So again, what makes this problem complicated is it's using tools from Chapter 10, and it's also requiring you to dredge back in your memory to use tools from previous chapters and working with attribute tables. So the expectation is once you have this done, it'll add this new field. Even though you called it distance in miles, just keep in mind it adds an empty field. And so notice all the values presently are null. It doesn't know what to put in those individual cells. So to populate those, we're going to use the field calculator. They call it calculate field. So you right click on the header and then choose calculate field. This allows you to do mathematics to do it, to change these values. And in this case, we want to take the values of distance in feet, which is here. Double click on that. That brings the name of that field down here, and then hit the divide by. And then you simply put your cursor down here and type in 5280. You can look up that conversion. That's just 5,280 feet in a mile. So this will then convert over to miles. So we should see then, I have to go find it again. It keeps kind of resetting. And here it is. So we have numbers that look about right. 2 miles, 1 mile, 2.7 miles, 2.2, 6 miles, and so forth. This looks about right. If those numbers were like thousands, you'd be kind of suspicious. If they were like tiny fractions of a number, that'd be suspicious. But 1 or 2 or 5 or 6 miles seems about right for the distances. So that's probably accurate. And then we'll right-click on this header. This is step number 3 of 3, and that's run the statistics on this, what we're looking for to answer the question, what's the average, and what's the median, what's the mean, what's the median value of the distance from schools to the nearest tennis court. Here are those numbers. Turns out the mean value, which is the average, is 1.88 miles away. Median 1.44, and then it builds a little histogram that shows most schools, 55 of them about, are under 0.7 of a mile away. Very few schools, like under 5, are 6 miles away from the nearest tennis court, is what this little histogram is telling you. And then it shows on here the median value, the mean value, where that falls on here is under 2 miles away. So to answer that question, mean and median, and then I think was there a requirement to create a histogram in distance in miles and capture it. So then you would type in those two and then do a screen capture of this distance in miles histogram, and that's going to be the answer to question number 1. Okay. What I'll do is maybe I'll demo a couple, then I'll hit pause on this, and then I'll have these saved in bits so you don't have to watch all of them just to find your way to number 4 or something. Any questions about number 1? That all made sense? Okay. I'll record 2 at a time and then I'll hit pause. So then we'll do question number 2. Anybody want to see number 2? Okay. So, all right. So number 2 reads, a study is being done to evaluate the staffing levels of police departments, determine the number of people living in each district, map and chart the results, and discuss them. And then, can you explain why some of the districts have such low numbers of people? I kind of wish that when she wrote this one, she would just say, tell me the average. Give me some numbers that I can be sure are right. She just says map and discuss it. It's kind of a vague request on her part. But nevertheless, we can make sure we set this up in the right way to get the answer, the map that she's looking for. Okay, so with this, she wants us to use police districts and the block population and points living in each district. So to set this one up, again, what I'll do is I'll go to insert a new map. I'm going to call this one EX2. we need the block population, and we need the police districts for this one. Okay, block population is there. They're both in the administrative feature data set. Looks like I've added it in kind of a weird way. It's okay, we'll correct it, do it that way. So we have the two layers that have of interest. This shows the polygons of all the police districts, and then the individual points, what those represent is when they conduct a census. Those are the most fine resolution data that the census data are published on. One block at a time, and we tell you how many people live on that block, how many houses are on that block, how many are owned, and how many are rented. So it tells you basic statistics about the people who live there. The only column of interest that we have to answer this question is what's the population 2010 is what she's looking for. So if I open that attribute table, the column of interest is this one, POP 2010, and there's going to be multiple points that fall inside of each of those districts, and we just want to sum those all up. This is a classic one-to-many, where there's many records trying to sum down to one. So let's read this problem again. I kind of got ahead of myself. Like when you think about which one's the target and which one is the join, we want, the way this problem is phrased, we want to know how many people live in each of these police districts, which makes that the target. The block population points is the join feature class where the data is coming from. And so when we perform this join, what we want to have is a new attribute added onto the police districts table. And here's that police districts table. And the way it is right now, they have a number of attributes on here: input date, modified date, input by, sector, and then it ends with shape length and LEN. And after we perform this join, what we're going to be looking for is a new column that is the sum of all of the points and the population 2010 of those points themselves. That's what we want this to result in. I alluded to last time that it's going to be important to use the fields, and the field we want from the population is the POP 2010, is this field right here. But if she'd asked the question differently, how many households are there, we would use households instead. All right, so to get this started, this is my recommendation. Always go from the table of contents, right-click on the layer you want to be the destination, what they call the target feature class. So I'll right-click on there, initiate it from right-clicking, go to joins and relates, and then add a spatial join. The target feature in this case is already auto-populated because that's the one I initiated it on by right-clicking. If you see that's otherwise, make sure and change it. And then the join feature is going to be the block population. And then because this is points and polygons, what we found when we ran this last night is we need to use the contain as the operator, the match option. The default is intersect. We want to use contain. So basically this is saying which polygon do each of those points, which one contains them, which one surrounds that particular point. And then it's going to give up its attributes if it's inside of one of these purple polygons. All right, search radius we don't need. We just need it to contain. But if you just hit OK right now, the downside to this is whichever single point it first occurs, which one it decides is the first one that it encounters, it'll give up its attributes to it. We don't want that. So if you pull down the fields list here, it gives you all the fields of the block population, because that's the join feature class. So we should recognize all of those names in this list as being the column names from the attribute table of the block population layer. And the one that we want is block population 2010. So if we really wanted to clean this up, one thing I'd recommend is just Xing out the ones we don't want. And then it would only give us the one we do want, because they're just kind of messy and not needed. So I kind of like to just remove the ones we don't need. I'm going to remove households, household units, FIPS, block, none of these things, track, we don't need these. County FIPS and state FIPS. The only one we care about is the population 2010. And of those, the merge rule as it is here, the default is first. Sometimes it might be you want the average. Sometimes you want some other account of them. In this case, it's important for us to get the sum. How many people live in each of those police districts? And the way we answer that is to sum them up. So I've gotten rid of all the extra fields we don't need. I switched the type to sum, and I'm going to click OK. So again, what we hope to have is for the police districts, we're going to have a new column added on here for the number of people 2010 who lived there. So I need to go back to the police districts to see if this worked. I'm going to scroll all the way to the right, and there's the new column on there. It says POP 2010, and we know because we set this up ourselves that this is not the first occurring, it's not the average, it's the sum of all the people who live there. And in her little notes, she says, or on the right answer, it says your answer for this should range between 3 and 67,000. So if we sort this column, in fact, the lowest is 3, and then if we sort descending, the highest one is, well, I guess it's 58,122. So we're getting the right answers on that. And what this is telling us, we can then, what she wants for an answer is for us to use the symbology and make a map out of this to show it. So remember, this is going back to chapter 2. We right-click on the police districts, go to symbology, and then switch it. The default is single symbol. That's why they're just all purple polygons. Switch it to graduated colors. Make sure you switch the field that it's pulling those numbers from to the POP 2010. And right now it's just it defaults to 2 classes. Maybe we can move that up to 5 or 6. And now it's showing here in these different shades of this kind of blue color, blue to yellowish blue to dark blue. We have 3 to 5,800, and then 5,800 to 15,000, and then the top category is 37,000 to 58,000, and that's the distribution. Then basically her question is, why is it that some of these have such a tiny population? Why does one whole district just have 3 residents in it, whereas other districts, the same, like another police department, serves 58,000 people? What a disparity that is. So then you're supposed to just speculate on, not a right answer, but just give some rationale for why they would draw district boundaries in such a way that some cover so few people and some cover tens of thousands of people. Ideas like maybe there's a university there, they don't count university, students at the university as permanent records. They get counted back home, not at the school location. So maybe there are a lot of people there, they just don't show up in the census. Or maybe it's the downtown and it's a business district, which there's not a lot of people who live there, but nevertheless they need a police force there to service those businesses. And so they still have a police district, even though there's not a lot of people. Or, so just any reason you can think of that there's not, they don't design these police districts around the number of people who live there necessarily. So just come up with a couple reasons. But if your map looks something like this, when you put it into 5 classes based on a natural break, you'll know you've got the right answer for that number 2. So this was a more simple one. It's the key here is to remember you need to go into the fields to tell it the sum of the block population 2010 to handle that one-to-many join. All right, let's jump to number 3. What I'm going to do is just hit pause on. Okay, so I want to hit